We are talking about conditional probability and the intersections of events. So the rule for computing P of F given E, that's what that line means, is given E, by counting, we're going to find the number of E intersected with F and divide by the number of E. So for our first example, we're going to roll 2 dice and the total showing is greater than 9. We want to know what is the probability that the total is odd. So we're going to let G be the event we roll total greater than 9, and O be the event the total is odd. So let's go look at this. So for example 1, we have G equal to, so G is going to be greater than 9, that's what we decided. So if we're looking at greater than 9, it has to be like 10, 11, and 12. So we would have 4, 6 would be 10, and 5, 5 would be 10, and 6, 4 would equal 10. And then 5, 6 would be equal to 11. So with us rolling a 6 and then a 5. And then for 12, we would have 6, 6. So that would be greater than 9. And of those events, if we're looking at the odd, where the total is odd, these all equal 10. The only two that equal an odd number, which is 11, will be 5, 6, and 6, 5. So if we're looking at the probability of getting an odd number when given that we rolled something greater than 9 is going to be equal to the number of O or odd intersected with greater than 9 divided by the number of the ones that are greater than 9. So the intersection would be 2. We have 2 that totals there, or rolling of the dice where we're getting that odd number when it is given that it is greater than 9. And then the number that were greater, we had 1, 2, 3, 4, 5, 6 possible rolls that would be greater than 9. And so that would be equal to 1/3. So, and if you're in the class, you can see the handout. Here we've got all of the listings of greater than 9 in the G, and in the odd, with an odd total where they overlap. So, we're not worried about getting all those other odd totals, we're just looking at the overlap between them. All right, for example 2, the State Bureau of Labor Statistics conducted a survey of college graduates comparing starting salaries to majors. Their survey results are in the table. If we select a graduate who was offered $40,001, between $40,001 and $45,000, what is the probability that the student has a degree in the health fields? So we're going to look at our table over here. And so our $40,001 to $45,000 is our category here, and then we're looking at the health fields right there. So we're looking at let's get a different color pen here. So for example 2, we're going to have R equal to the starting salary that is between $40,001 to $45,000. And then H will be the degree in the health fields. So we are looking, again, they want to find what is the probability that the student has a degree in the health fields if we select someone who had made that, who was offered between that. What's the degree, if the degree was in the health fields? So we're looking for the probability that they have a degree in the health fields given that they were given an offer if that starting salary of $40,001 to $45,000. So first we need to find the probability of R, and that's going to be the total that we're looking for. So R is the starting salary. Our totals are down here, so we have a total of 15. All they did was add all the categories. I know that's kind of hard to see. Let's zoom in for a second. Maybe if we turn out the light. Still a little hard to see, at least from the distance. So we've got 15 on this total, and for our health fields, we're going to have a total of 14 right there, but what we're really looking at is the intersection. We need to know this total and the intersection. So let me pull it back up a little bit here. So the probability of R is equal to 15, and these were totals in percent. So we have to change them to decimal places. So this would be equal to 0.15 by moving our decimal place over 2 places to the left. The other part we need to know is the probability of health fields intersected with that particular salary pay. So if we looked at that, we figured out that that was 3, and again, these were given in percentages, so it'll be 0.03 when we move our decimal place over 2 places to the left. So just recall, those were in percentages, and it said that in the corner right there that they were in percentages. So if we're looking at the probability of H given R, or they had a degree in the health field given that they were given an offer in that salary range, then at the top we'll have the probability of that should be an R, the intersection between the health fields and that particular pay, and it'll be divided by the pay, the probability of that. So the intersection was 0.03 divided by the probability of that pay is 0.15, and that'll get us 0.20, which will be 20%. So we just got to find the values that we need. We don't have to know a whole lot of things, we just got to know a few things. All right, so let's go look at the rules for computing the probability of the intersection of events. So if E and F are events, then the probability of the intersection will be the probability of the event times the probability of F given E. The rule says to find the probability of this, we first find the probability of E, then multiply it by the probability of F, assuming E has occurred. So we're going to estimate your grade in class. Assume that for your literature final, your professor has written 10 questions on 10 assigned reading on cards, and you are to randomly select 2 cards and write an essay on each. If you have read 8 out of the 10 readings, what is your probability of getting 2 questions that you can answer? So if we look at this formula real quick, I want you to notice this equation is the same as what we have here. So if we just multiplied by the PR on both sides, it would be over here, which is what that is. Like it'd be P of E times P of F, oops, you can't see, P of E times P of F given E. Well, we would have P of R times P of H given R. So if we just multiply by both sides by that, it's really the same formula. Things are just getting manipulated. All right, so let's go on to example 3. So for example 3, we're going to say that A is equal to, you can answer the question. So the first question. Yay, you can answer the first one. And B will be equal to, you can answer the second question. So we need to find the probability of A and the probability of B. So the probability, again, was that what we're looking for, just to remind ourselves, we assume that for your literature final, your professor has written 10 questions on 10 assigned readings on the cards. You are randomly to select 2 cards and write an essay on each. If you read 8 of the 10 readings, what's the probability of getting 2 questions you can answer? So the first one means you draw from 8 out of those 10 that you know. So it'll just be 8 out of 10. But if you can answer the first question, that means you've used one of them. So now there's only 7 questions left that you could answer. And that would be the probability of B, that you could answer the second question. The first time you have the possibility of getting 8 out of 10, and then the second one would be 7 out of 10. So if we want to find the probability of A intersected with B, we will find the probability of A times the probability of B, given that A has occurred, which is what that means. So this was probability of B, given that A occurred, because we said A occurred. That took away one of the cards that we knew, and so that left 7. So to find this, we're going to take 8 out of 10 times 7 out of 10. 8 times 7, sorry, it's not out of 10, is it? This is out of 9, so sorry. This should be, let me rewrite it, 7 out of 9. And this should also be a 9. Sorry about that, because there was only 9 cards left. The first one, there were 8 out of 10. You knew 8 out of 10. But now, because one card was pulled away, there's only 9 left. So it's 7 out of 9. Sorry about that. Got to watch that part because we took care of one. So 7 over 9. So 8 times 7 would be equal to 56. And 10 times 9 would be 90. And if we put that in the calculator, we get approximately 0.62. Changing that to a percentage, we move the decimal place 2 places to the right, which would be 62%. So the probability of being able to answer both questions would be 62% chance. So if you think those odds are good, you don't have to read the last 2 books. But if you want a better odds, you're going to have to read the other 2 books that were on the list. All right, our next question. We're drawing colored balls from a dish. After winning a carnival game, Evan will draw 3 colored balls consecutively without replacement from the dish to determine his prize. If he draws 3 red balls, he can choose one of the most desirable prizes. What is the probability that he will draw a red ball, and a green ball in that order? All right, so I know you can't see the colors. So I've written out there are actually 3 red balls. Those are like the really dark ones. 5 blue balls and 7 green balls in the dish. So he's trying to draw a red, and a green. All right, so for the first one, so this will be example 4. So for stage 1, he's looking to draw, stage 1. He's looking to draw a red ball because we want a red ball, and a green ball. So for this, we get the probability of a red ball. So probability of red will be equal to the red out of the total. Well, we were told that there were 3 red balls divided by, we were told there were 15 balls, I believe. Let's see, did it say 15? Nope, I don't think it actually said it, but we can add it together, right? So 3 plus 5 would be 8, and 8 plus 7 would be 15. So out of 15 total balls, and we can reduce that down to 1 over 5. Now for stage 2, which is like a step 2, because now he's trying to draw another red ball, he wants to draw his second red ball. So the probability of getting red, given that we already drew a red ball, so remember that line always means given. We already drew a red ball in the first one. So this will be equal to, again, how many red balls do we have? and what's our new total? So we're still looking at red, given the total. So now we drew one red ball, so there's no longer 3, there are now 2. And the total is no longer 15. We took one out, so now there's only 14. And that will reduce down to 1/7. So our third stage, or third step, is that he's going to draw a green ball. So now we're looking at the probability of drawing a green, given that there were already 2 red drawn out. So for the number of green, we were told there were 7 green balls. So it'll be the green out of the total. It's the current total, just so you know. So 7. Now we already drew, again, so we started with 15, but we've already pulled out 2 balls. So 15 minus 2 will get us 13. And that won't reduce. But now to find that probability, we're going to take our 3 numbers and multiply them. So 1/5 times 1/7 times 7 over 13. When we put that in our calculator, we'll get 0.015. Moving our decimal 2 places to the right, we'll get 1.5%. So there is 1.5% chance that we will draw a green ball after drawing 2 red balls. And then just to briefly touch on independent events. Events E and F are independent if the P of F given E, so given that E happened, is still the same as P of F. So if they are independent and don't affect each other at all, then that makes them independent. And then if P of F given E doesn't equal the same thing as if we just took P of F, then they are dependent on each other. So this means knowing that E has occurred does not influence the way we compute the probability of F.